Hello friends, now today we are going to see the next topic from the curve tracing, which is rectification of curves. So here actually we are going to see how to find out the length of the curve with the help of some formulas. Okay, so let us see the formulas for rectification of curves. So these are the three important formulas we are going to need while solving the problems of rectification of curves. Okay, the very first formula that we have written, that is for the curve Cartesian curve. To find out the length of the curve for y equal to fx from x1 to x2, that means this will be the lower limit and the upper limit for your integration. Okay, so from x1 to x2 we are going to find out the length of the curve. So the formula for the rectification of curve is denoted by s. So s is equal to integration from x1 to x2 under root 1 plus dy by dx whole square dx. Okay, so this is a very important formula. To if you have a Cartesian curve and if you want to find out the length of the curve, we want to make use of this formula. Similarly, suppose if you have a equation in terms of f of y, that is x is equal to f of y, then what will be the changes? The changes in the formulas will be the length of the curve we are going to find out from y1 to y2, and the formula will be under root 1 plus dx by dy whole square dx. Okay, but mostly you are going to have problems on y equal to fx kind of curve. Okay, so this is for Cartesian. Now next let's move to the next problem, next formula of parametric curve. So if you have suppose x is equal to ft and y is equal to gt, and if you want to find out the length of the curve from t1 to t2, then the formula will be s is equal to t1 to t2 under root dx by dt whole square plus dy by dt whole square into dt. Okay, so simply you are going to have x, you are going to have y. Simply find out dx by dt, find out dy by dt, take the square of it, add it, take the square root, and then you integrate. You will get the length of the curve. And the last one will be the polar curve, r is equal to f of theta. And if you want to find out the integration from theta 1 to theta 2, the formula will be s is equal to theta 1 to theta 2 under root r square plus dr by d theta whole square d theta. So again r will be given to you, so you can easily find out dr by d theta, take the square of it, add r square to it, and then take the square root, and then integrate between the limits theta 1 to theta 2. Okay, so these are the formulas. Now based on these formulas we will see some example. So we are not going to solve much example, but let us start with the one example on Cartesian curve. So we want to find out the length of the loop. Okay, underline this. We want to find out the length of the loop of the curve 3y square is equal to x into x minus 1 whole square. So this is a Cartesian curve. We are having v of y in terms of x. Okay, and if you look at the symmetry of this curve, the symmetry of this curve is about x-axis, because the power of y is even. Okay, so the loop that you are going to have, that will be the half part of that loop is above x-axis and half part of the loop is below x-axis. Okay, because of the symmetry. Okay, so if you use the formula for Cartesian curve is s is equal to integration from x1 to x2 under root 1 plus dy by dx whole square. To get the length of the curve, we are going to need dy by dx. Okay, so your y will be, when you take the square root, your y will be root x into x minus 1 upon root 3 when you take the square root. So let us take the derivative of this. So dy by dx is what? It will be x by root 3. I'm simply applying product rule over here. So what I'm doing, I'm keeping this x by root 3 as it is, and the derivative of x minus 1 is 1. So that is your first part. Plus, second part will be what? Now I'm keeping x minus 1 upon root 3 as it is, and the derivative of root x will be 1 upon 2 root x. So it will give you the derivative of y as this. Okay. Now let us put these values in the formula. To your if you simplify it, you are going to get dy by dx as 3x minus 1 upon 2 root 3 root x. Now put this value of dy by dx in the formula. S is equal to integration from x1 to x2 under root 1 plus dy by dx whole square dx. Okay. Now the important thing is the limits. Okay. Now how we are getting that 0 and 1. Okay. So as I told you, we want to find out x coordinate. X coordinate means what? We want to find out x intercept. Okay, that is the intersection of that curve on the x axis. Now to get the x intercept, simply what you will do, you put y equal to 0 over here, and when you put y is equal to 0, you are going to get two values of x as 0 and 1. So these are the limits of your integration. So your limits will be x to 0, x equal to 0 to x is equal to 1. And then I'm simply putting the values of dy by dx over there, and I'm squaring it. Now when you simplify it, when you take the square, so we'll get a next term as 2 times 0 to 1 under root 3x plus 1 whole square. And now since we are getting the whole square, the square root and the square will get cancelled out, and we are going to get simply 2 times 0 to 1 3x plus 1 upon 2 root 3 root x. One more thing, why we are getting here 2 times. Now why 2 times? As I told you, the symmetry of the curve is about x-axis. So actually here this part will give you the length of the loop above the x-axis. Similarly, to get the length of the loop below the x-axis, the same length will be there. That's why we are making it 2 times. Fine. Now simply if you separate it and when you integrate, you are going to get I'm taking a 2 root 3 outside the integration, and then I'm separating the terms over here, separate the terms, and then you integrate. So integration of root x will be x raised to 2 by 3 upon 3 by 2. It should be 3 by 2 over there, plus 2 into x raised to half, and then we are going to put the limits 0 and 1. When you put the limit 0 and 1, you are going to get 1 upon root 3. When you put 1, it will be 4, and when you put 0, it will be 0. So your final answer will be 4 upon root 3. So in this way, we are getting the length of the curve or length of the loop over here. I hope the important thing that you have to remember is why 2 times, because the symmetry, and why 0 to 1 limit, because that is nothing but your x intercept. Okay, I hope you are getting this thing. Now let's move to the next problem. Find a parameter of cardioid r equal to a into 1 plus cos theta, and show that a line theta equal to pi by 3 divides upper half of the cardioid. Now cardioid is nothing but a curve which is a heart-shaped curve. Okay, this is a polar curve. I hope you remember. So here, while tracing this one, your curve will look like this. Okay, this is nothing but your r equal to a cos 1 plus cos theta. So you can simply check out, when you put theta is equal to 0, your length of the r or the value of r will be a, and you can easily trace that cardioid. Okay, now basically there are 4 types of cardioid: a into 1 plus cos theta, a into 1 minus cos theta, a into 1 plus sin theta, a into 1 minus sin theta. Try to trace all this thing. Okay, now here what we want to prove, the perimeter. Perimeter means what? The length of this whole cardioid. We want to find it as is what? Show that the line theta equal to pi by 3 divide the upper half of the cardioid. That means here what we are going to find out, what we have to do actually, for the upper half of the cardioid, whatever is the length, okay, suppose it is b, suppose. So what they are saying, theta equal to pi by 3 divides upper half of the cardioid. That means when you integrate the whole part, if you are getting a, now when you integrate from 0 to pi by 3, you have to get exactly half of that, that is a by 2. If you are getting this, then we can say the statement is correct. Okay, so what I have written over here, see, curve is symmetric about the line initial line x-axis, because when you replace theta by minus theta, equation remains unchanged. Therefore we are having symmetries about initial line. Fine. Now for upper half of the arc, theta varies from 0 to pi. Okay, that means if you look at the upper half of this curve, your theta will vary from upper half is 0 to pi. Okay, so let us find out the length of the full part or the above the x-axis. Since the curve is given in the polar form, we have to make use of this formula. So s is equal to 0 to pi. So listen here, for s we are going to find out 0 to pi means what? The whole part above x-axis we are finding. 0 to pi under root r square plus dr by d theta square d theta. Now we are having the value of r, dr by d theta will be what? A minus a sine theta. Then you take the square of r square, take the square of dr by d theta. When you add it, you are going to get something like this, root of root 2a into root of 1 plus cos theta. Now when you put this value in the formula, s is equal to 0 to pi root 2a into root of 1 plus cos theta. I hope all of you remember that 1 plus cos theta can be written as 2 times cos square theta by 2. That I'm putting it over here. Root of 2a I'm taking outside the integration. Okay, so what you are left with, 2a integral 0 to pi cos of theta by 2. Now the integration of cos of theta by 2 will be what? It will be sine of theta by 2 upon half. So that 2, when you take it in the numerator, it will become 4. So it will be 4a sine of theta by 2 pi and 0. When you put the upper limit, it will be 1, and when you put lower limit, it will be 0. Therefore the total length is 4a. So remember that the length of this part is 4a. Okay, now what I want to prove, I want to prove that up to this it is exactly half. I want to prove up to this it is from 0 to pi by 3. It should be 2a. If we can prove this, then we are through. So this gives the length of the upper half because of the symmetry of the curves, perimeter of the cardioid. If you want to find out a perimeter, the full part, the perimeter will be what? 2 times of 4a. That will give you 8a. The perimeter, the length of the full cardioid is 8a. Okay. Now to prove the second part, we integrate it between the limits 0 to pi by 3. Now the integration will remain same. Okay, so this part will be same. Only the thing is we are changing the limits from 0 to pi to 0 to pi by 3. Okay. Now when you integrate it, when you put the limit 0 to pi by 3, you are going to get the answer as 2a. Okay, if you observe over here, 2a is we are getting, which is exactly half of the upper part. So we can say that a line theta equal to pi by 3 divide the upper half of the cardioid. I hope you are getting this thing. So that's it for today. Thank you everyone.